So let me first take a common question from all. So this is about the industry trend in advanced materials, and it is a mix of epoxy, functional polymers, polycarbonate, nanomaterials, composites, smart materials, biopolymer, biocompostable, and others. And so we want to know the industry trends, and apart from that, the application areas being developed for advanced materials, and what's the future outlook. So let me start with you, sir. And
what about Excel? Shroff, sir? Yeah.
I will go to Shroff, sir, later. So you can start, sir.
Yeah. As far as the advanced material technology is concerned, functional polymer, we are seeing a great opportunity for functional polymers across the globe, including India. If I tell you what is functional polymers are, the polymer which are backbone with thermoplastics, and then they are functionalized by various chemistry like epoxies, anhydrides, acids on the backbone. It creates what you call is modifiers, impact modifier, chain extenders. It can be a recycled resin. It can be products to bind two polymers together. So when you have a polar and a non-polar chemistry, you need something to functionalize to bind together. In terms of opportunity, in terms of India, and if you look at the product category, it touch bases all the industrial applications, including automotive and engineering plastics, EV, electrical vehicles. It takes a good amount of responsibility on HFFR, which is wire and cable and optic fiber. It has a fantastic relationship in tie layers for multi-layer plastics. Sustainability, which is the biggest market today we are talking about across the world, is recycle. Without functional polymer, you cannot have a homogeneity between the two mixed plastics. So recycle is a very, very big opportunity which we're seeing. In addition to bitumen modifications, pipe coatings. As we speak, the opportunity which lies for India, globally there are a handful of people like DuPont or Dow's. India has never been seen as a manufacturer. Although we are doubling and tripling compounding capability, automotive, we are the second largest in the world. But when you look at additive manufacturing, we are hardly anything. And that's what we saw a gap, and we, like today as we speak, we are coming up with our next round of expansions. But today, globally, there's a huge opportunity for functional polymer, next generation polymer like a graphene, like carbon black, like any advanced technology with thermoplastics, with TPU, polyurethanes. So I see a huge opportunity for advanced material in functional polymer chemistry.
Thank you, sir. Now I go to Ashwin, sir. Sir, are you there?
Yes.
So if you can talk about, sir, industry trends in advanced materials.
Yeah. Okay. I will give a kind of general context. I'll do it quickly. One is, I think we are living in a particular context, so we need to understand the context. And very rightly, you have put as part of the theme is that sustainability is as important as what you want functional properties or functional products, but they have to be put in a sustainability context. So we cannot only be talking economy, we have to talk economy and ecology, environment, society, all of that. Climate change is, for example, a big problem. So what we need, as was said by the earlier speaker, that we need products with functional properties, but they should not hang around in the environment. They have to degrade, they have to die, they have to get recycled, etc. And similarly, processes, we need green chemistry, for example, sustainable processes, wherever possible, biotechnology, etc. So this is the context in which we are talking. And later, if you like, I will share some of the specific thoughts. However, this is the context in which we are living, and this is the demand of the times.
Thank you, sir. Now I come to Yogendraji. Sir, if you can throw some light on the industry trends and...
Yeah, so advanced material, I mean, the name is getting rightfully very good popularity in Indian context. So now many conferences like today's is having a dedicated session on the advanced materials. So that itself says that how our kind of a requirement, industry requirement, market requirement, and consumer requirement is compelling us to make materials which are really in a way smart. So when I say smart, definitely energy efficient, definitely in terms of having a longer life cycle, having a capability to either mechanically modified or chemically modified, at the same time have a capability to replace conventional material, including conventional polymers and conventional inorganic material, glass, ceramic, or metal. So this, in my opinion, is what we talk about the advanced material. So the materials which is actually ready for the current market requirement and future requirement. This is how I see the advanced materials.
Thank you, sir. Neeraj ji, if you can throw some light.
Yeah, thanks, Pravin. So I'll touch base on the epoxy industry, how it is evolving. So it's a very traditional and chemical, thermoset kind of the chemical, which has been in use in the industry since 1950s something. And traditionally, it comes from the petrochemical background, from the phenol and propylene as a major source of the raw materials then. But in the past 10, 15 years, a lot of work is happening to make it more sustainable, bio-based and green chemistries, in which whatever sources can be replaced by the bio source. So the work is happening towards at least to have some bio-index that the epoxies which has got developed having a 30% of the bio-index something, make it more sustainable for the future. That is from the epoxy chemistry side. The other development which is happening, that the uses of the epoxies, it has always been used mostly for the sustainable growth of the economy, because it has a very high corrosion resistance, so it goes for the coatings, and a lot of uses in the composites, which again makes the durability higher for the materials. But thermoset resin, by definition, they cannot be recycled. So the recent development which has happened, in which I would like to share that our company, which has developed a version of thermoset epoxy resins, which can be recycled at any point of time, at end of the life or before that, first in the world, and commercialized and being used now. So with this goal that making thermoset resins also recyclable for a sustainable future and sustainable growth, this is coming into the picture in the epoxy industry. Thank you.
Thank you, sir. Vivek ji, your views?
Thank you. Good evening, everyone. I will talk about basically an advanced material for composite materials. The industry I represent is basically for glass composites. And as we see development and trends towards glass composites, currently the market is standing around 300 to 400,000 metric tons annually. And there are three basic segments which contributes almost equal share in this glass composite market. That is wind energy, second is automotive, or we can say broader way mobility, and third one is industrial, where there are many applications like pipes, telecom, as well as even construction. Talking about specifically uses or trend in wind industry, as turbine sizes are increasing, actually there is a continuous increase in the demand for glass composites. There is also focus for increasing the renewable content in overall energy basket of the country. So there is government target by 2030, at least 50% generation has to come from renewable energies. And that's where we see a good demand for glass composites coming. Also, as turbine sizes are increasing, there is increased requirement for higher modulus products, where we see even carbon composites gaining more and more traction, which could increase their percentage in the wind turbine blade manufacturing, could be somewhere around 30%. So those are the advances we are seeing wind industry. Coming to mobility or transportation and EVs, where we see a significant interest is getting generated. Lighter and efficient vehicles are actually where we see glass composites and other composite materials which has edge over traditional metals, can create a more demand. However, as alternative technologies are developing and there are challenges around infrastructure for EVs, there could be some time we have to see till this demand picks up. And coming to the industrial side, actually I see construction is the industry which is showing recently more interest and good potential for glass composites, basically for composite rebars, which can replace even the steel rebar in some areas of construction. And this interest actually is actually showing that there could be a big potential for this application where new manufacturing capacities, both from producing rebar as well as for the reinforcement material as well as epoxy resins, new capacities would be required. So if we see these three basic segments, there could be definitely around demand increasing, approximately doubling the requirement market size in over 8 years' time. So we expect somewhere around 12 to 13% CAGR growth for composite materials in coming time. Thank you.
Thank you. Nirjhar, your views?
First of all, thank you, Pravinji, for inviting me to this esteemed panel. I think sustainability is being the topic of the day. I think this also is, this is one of the major trends that is coming up. As IMCD, how we see sustainability is broadly into 8 major categories. And you spoke about trends, but it's important that we define sustainability as well. CO2 reduction, recyclability, biomaterials, biocompostable, end of life, weight reduction, waste reduction. So these are the major categories that how IMCD sees sustainability. So when all the esteemed speakers were talking about, someone touched upon recyclability, someone touched upon lightweighting, which is the thermoset composite part. So we are also in the same journey. I think the mega trends would fall with different applications. I think automotive, everyone has already touched. But I just want to also tell the basis for that, because if you see traditionally, IC vehicles were supposed to be lighter vehicles. But as we are moving towards new energy vehicles with CNG, with hydrogen, with hybrids, the weight of the vehicle is getting increased. And if, as in the previous discussions, if the weight of mobility increases, it hampers the efficiency, which is again not sustainable. So we have to look at lightweighting solutions. Now it could come from composites, it could come for thermoplastics, it could also come from combinations. We are also working with a lot of products where we have thermoplastic and we have carbon fibers combining together and giving the right solution. Lightweighting for automotive would be the key thing, but again, with automotive, India is a price-sensitive market. Carbon fiber as a concept, as a solution is a great solution, but in reality, when we talk to the Maruti Suzukis of the world, they are more inclined towards aluminum. So I think carbon fiber also needs to take that, and again, it comes down to cost, but I think I will leave that for a different topic. I will also touch upon packaging, because packaging was also something which was spoken about earlier. I think multi-layer packaging, I think Mr. Vishal touched upon tie layers, but I think multi-layer packaging is also a big challenge in terms of sustainability, because it's hard to recycle multi-layer films. So the solution for that could be monomaterial. That is something that we are working on in Europe. And and again, data centers was another topic. As the data centers would increase, there is more and more requirements of the cables. It has to be PFAS free. So these are the general mega trends that are happening in the world today. India on the sustainability front is not at the top. I would say Europe would be the country that is at top. We being a multinational company, we see trends happening in Europe, which we would also like to see in India. When we speak to the European OEMs, they do not encourage any inquiries or any RFQs that do not have a sustainable solution, because they are working on a carbon credit. They also get incentivized if they sell EV vehicles, but end of the day, they have to show the usage of sustainable products in their system. If they fail to do that, they have to be penalized for a 15,000 euro penalty per vehicle, which is a huge amount for any OEM, and then that's when the carbon trading happens. But similar regulations are required in India as well, and I think People are talking about sustainability, but I think it's high time that India should step up in terms of regulations, in terms of the capacities, in terms of the investment, so that people, because it is the need of the hour, as we discussed in the morning.
Thank you, Nirjhar. Coming to Ashwin ji, sir, what role can India play in building global value chains for sustainable materials, particularly in rare earths, bioplastics, or nanotech sectors? So over to you, sir.
Yeah, okay. So I'll touch to two dimensions. One is the kind of raw materials or the feedstocks that we can use, which are available and which have not been fully recognized. So to take some examples, let's say cellulose, which comes from agricultural residues, many other sources, is something which is nature derived, which can be converted into various applications, various products, etc., and is degradable. So let's say if we take polymers as a segment, the good old plastic cellulose acetate is something which has been known for a long time. It has been sort of put in the background. It needs to be brought in the forefront. It is biodegradable, not as quickly as one would like, but compared to the petrol-derived polymers, it is much faster. It's few months, and it can be expedited with various things, including biotechnology. So this is one area. Then let's say there's a lot of talk about rare earths being required, which are and without that the EV vehicles cannot come. The motors in the EV vehicles are not without possible without the rare earths. We have mining residues. We have got coal ash, which is available from the thermal plants, which are rich in rare earths. We need to extract them. All technologies may not be available, but for example, we are working along with the CSIR laboratories and other institutions. IMMT, for example, Indian Institute of Science, IIT, etc. A lot of knowledge is available. We need to collaborate, industry, academia collaboration, industry research collaboration. Even within the industry, we can collaborate and complete the whole value chain. The third area, a wonderful raw material which we can do in India. Globally, it's reasonably well known, not grown specially, but grows naturally, but it can be even scientifically grown, is seaweeds, which grows in the ocean. You don't need land, you don't need fresh water, you don't need fertilizer, pesticide, nothing. So it's agriculture, it's photosynthesis based, so absorbs the CO2 on one side on a huge scale, and is a wonderful renewable raw material which gives a source for many things, including bioplastics, including fertilizers, including human food, cattle feed, etc., and also nutraceuticals. So these are examples of the kind of raw materials that can be sustainable and which are available abundantly, which we need to recognize and use them. So, so renewable materials, abundant waste which are available is what can be looked at. And India can play a big part. Let's say the cellulose is available very much. The rare earth is available very much in our mining residues. Even critical metals are available. Critical elements are available in India out of our residues, mining residues. Red mud, for example, from the aluminum industry is a wonderful source. So there are many sources that we are sitting on, and we can become a supplier, we can become a processor, value adder, and then we can be part of the global value chains. Thank you.
Thank you, sir. Neeraj ji, you have been innovating a lot on the epoxy chemistry and doing a lot on the wind turbines out of it. So how are you helping in terms of sustainable growth, if you can throw some light on that?
Yeah, so as I told earlier also, that in epoxies, traditionally they are the thermoset resins, so they can, any composite which is made out of it cannot be recycled. So we have developed chemistry, epoxy chemistry with a product which is patented and known as recyclamine. So once the epoxy resin with recyclamine, it is being used to make any of the composites like wind blades. They can be recycled at any point of time when it is required or at end of life. Now, why this is important for the sustainability of the industry? We all are seeing there is a lot of growth happening in the wind industry. Wind turbines are being put up all across the world. More than 100 gigawatt of the wind capacity addition happening every year. all these wind turbines with the wind blades, which are measuring from on an average 20 tons single blade weight. So millions of tons of this composite waste is going to come for the recycling in a next 10 to 20 years time. And earlier it was being used as a landfill, which has been stopped in Europe and US and all other places. Actually, it should not be allowed in any part of the world. So the industry was looking for a sustainable solution for that. And few of the mechanical solutions, people are grinding it and then burning it, which is again energy intensive. It is not advisable. So the other method which now has been proposed, which has been used, and is recyclable epoxies. With this, the entire epoxy can be again recovered and used as a thermoplastic in different applications, entire glass fiber, all the material can be recovered and repurposed. So with this kind of the advancement in the epoxy industry, which is happening, and actually Europe has immediately taken up, and there are few of the projects which are happening where the wind turbines are with the blades, because in entire wind turbine, if you see, only the blade is the composite part which cannot be recycled. All other is the metal which can be recycled. Tube and your gearbox and generator and all those parts. So with this, actual recyclability and sustainability is coming to the wind industry with this. The second development in epoxy industry which is now taking place, epoxy as a material is used in a lot of coatings, in floor coatings and all applications, which was traditionally with the solvent based. So a lot of VOCs were the issues in the coating industry. Now a lot of water based epoxy solutions has been developed, which are being used all across. Just for an example, China is the biggest producer of containers, and all the container coating was earlier with the solvent based epoxies. They just got one law and changed the entire industry from the solvent based to the water based epoxies in 2017. So the entire solvent which was going into the environment has got eliminated, making it more sustainable. So same way, a lot of chemistries and work is happening. Now with the biosource of coming, because epoxies are made with the two major raw material, one is bisphenol A, BPA, and one is ECH, epichlorohydrin. So on BPA side, though, not much work is happening today to make it greener with the biosource. But on the ECH side, there are two chemistries. One is propylene based and another is glycerin based. So all new capacities are coming with the glycerin based, because being the greener source, biosource, and that is driving the sustainability into the epoxy industry and bringing more greener solutions to the industry.
Thank you, sir. Yogendraji, what are the new technologies which are being developed or under development in thermoplastics polymer space?
Yeah, so I mean, that's a very interesting question. So even though the thermoplastics are invented in last century and also in early part of this century, but the continuous improvement or innovation is happening. So thousands of patents are being filed to make next generation of the polymers or the processes. So one of them I can share with you is replacing, say for example, all our laptops earlier, including this MacBook and all, we were having a housing material as aluminum magnesium alloy. So now this is being replaced by polycarbonate or polycarbonate ABS compound having a glass fiber or carbon fiber. So having a same property, mechanical strength of a metal or aluminum magnesium alloy, but now replaced with a more recyclable material, lightweight and all. Also it can, lightweighting is done by having this material which are actually 30-40% lighter than the even the conventional material, right? So this is a kind of a one example. Another part is a continuous fiber reinforced technology. So this is also where you can have a variety of resin as a substrate, including epoxy, polyurethanes, and so forth, polyamide and all. So this is also being used for example, cable tray. No, traditionally cable trays were having a metal. So now cable trays are being provided by unsaturated polyesters as a kind of a resin systems impregnated and then having either glass fibers or other material to make it stable and also durable for a life cycle of 30, 40 years. And this is something which is really helping industry in a way, not only in terms of cost, but also in terms of, so a lot of industries are coming up in India for pultrusion. So, for example, styling or your SUV cars, right? You had a rail, roof rail, so mainly for luggage carriers and also for the styling features. So now it is being replaced. The metal roof rail are replaced by pultrusion technology. So this is another example. And at the same time, with all this Vande Bharat, the Indian Railway, and so we are actually initiating the project. How we can further help Indian Railways for lightweighting. When Indian Railway is really determined to further increase the average speed of the train, and that can only happen when you can replace the conventional wood and metal and all other alternate materials being used in conventional train with a lightweight and advanced material. And for that, not only injection molding and thermoforming, but the advanced technology is used. So you can replace not only the secondary treatment in terms of the coatings and all. So thus, by doing that, you can reduce the environmental impact. You can further improve in terms of production efficiency. So this is exciting field and more ecosystems, because now people are talking about China plus, and India is a very good market definitely for all this end product. So ecosystem is also moving from China and developed economies. So you will see more and more production technology, advanced technology also fast track to India, and we will see those kind of advancement in addition to the advancement in material development. That's what I can say.
You see graphene, 3D printing and conductive compounds.
Yeah, so graphene is very exciting material, even though earlier it was not affordable, and I think invented 30, 40 years ago. It's a two-dimensional material, graphene, as most of you are familiar with. And the research was in our 90s and early 2000 was restricted to the universities, including IITs and IISc. But now graphene and the consortium of graphene is also happening in India. The government of India, CSIR, is promoting the COE for graphene. And Deepak, at Deepak Group, we are promoting a couple of startup companies who are coming up to further use graphene in drone applications. Unfortunately, the wars are going up. So those defense equipments are also required to replace the metals and conventional thing. And graphene can play a big role. So the wonder material graphene can be used for membrane coating, can also be used for coating for electronics. Graphene can also be used for heat insulations, as well as conducting heat and dissipating heat. So this is another applications we talk about, the turbines. So the next generation of turbines, and I think that is what the rapid translation of the conventional turbines, which is used and you require offshore, onshore and all. But you must have heard about the new turbines which you can install on the rooftop of your home, like solar panel. So there graphene is also being tried, how it can play a role. So make it more efficient in terms of that. And battery technology, graphene can play a big role. Lot of research is being happening here, and all Japanese as well as the European companies are now setting up graphene related application centers and also the industries here. So you will hear more about the graphene. 3D printing is basically additive manufacturing. Again, it's a very old technology, got attention in last 15, 20 years. So additive manufacturing was earlier only used for prototyping. But for advanced medical devices and these implants, and also for the dental applications and all, because all of us are unique. So to have a unique fitting, you need a customized solution. And this is where additive manufacturing is also fast track, I would say. Now industrial scale 3D printing plants are also there in India. So the 3D printing machines of Stratasys and all other companies are being implemented, but also Indian companies are gearing up that after China. So Chinese, 15 years ago, they have started making their own 3D printing machines. Now Indians are doing. So the advanced drones for agriculture applications, for border security is also there. So those drones which can use for, even for the ambulance, you must have heard about the ambulance, the drone ambulances. So they are 3D printed. And there are 6 companies in India, they have a, if you get a chance, you should visit. They are there in 4 different parts of India, including Noida. Some of them are my customers. So they have a big 3D printing, industrial scale 3D printing manufacturing setup where they make drones which can lift weight from 20 kg to 180 kilogram of the load. So the human can be transported, the material can be transported in a remotest of the area. And this is another exciting applications of 3D printing, I can say. And I can go on and on, but in the interest of time, you are encouraged to contact me maybe after this session, and I will be happy to share more. Thank you.
If it has, I'm talking to Vishalji, if it has such a promise, are larger companies ready to invest in advanced material companies?
That's a very interesting question. When we look at innovations, we've seen innovations coming from startups. We've been seeing innovations coming from mid-sized companies. But where are the biggies in innovating? I mean, let's talk biopolymer. We've been talking about biopolymer. India is full of sugarcane. India is full of celluloses. Compostable biopolymer, there is a nomenclature in Indian single-use plastics. 2000, if I am right on my date, 1st July 2022, India came with a single-use plastic ban. Okay, so government has done its part of the job. We also had a single-use plastics ban for carry bags. But when you look at the raw material for biopolymers, we import PBAT, we import PLA, we import all particular polymers. So Reliance, the mother of petrochemical in India, has been talking about PBAT plant for last 3 years. I don't know what kind of patent they want. I would be faster than them to set up a 20,000 tons capacity of PBAT if I am being given a chance. Because you don't need so much of project on it. The big industries are looking at scalable projects. They are looking at investments only and only into something which is 100,000 tons to 10,000 tons. Let's talk about resin systems. I would absolutely congratulate Deepak Nitride, not from an advanced polymer background. Traditionally in a fertilizer, have taken a good step towards coming to polycarbonates. We have been a net importers of resins. So when we look at, if we want to really talk about India to be a true advanced material company, all the big organizations, incubators, investment bankers, venture capitalists have to invest in startups and mid-sized companies who actually have technology. So according to you, we are missing the whole scalability. And I was talking to Citibank's CEO. He said, Citibank invests in China on mid-sized companies, which are typically $10 million, who can become a $1 billion. Such 500 startups are there in China. But in India, we don't see those potentials. So we, as an industry, needs to look at those potential, scalability and investments. Then this can become in one generation and not go to the next generation.
Nirjhar, any change in supply chain strategies for advanced materials from your existing strategy, or?
So yes, definitely there is a strategy change because there is a technical know-how that is required. Traditionally, what distributors were supposed to be doing, because IMCD is a distribution company, distributors were also focused or seen as people who can provide the material at a lower cost. So cost was the driving factor. People evaluated a lot of companies based on the profit they make, but now things have changed. People are also viewing companies from a sustainability standpoint, or what they are doing from a sustainability aspect and how they are affecting country as a whole. The question comes is, a lot of companies don't know where to start. I think that's the bigger challenge that we have seen when we speak to our customers. So I frequently visit a lot of auto companies, a lot of packaging companies, and the problem that they have is, where do we start? So as a distribution company, such as IMCD, we don't consider ourselves just a pure distribution play. It's also a lot of technical support that we do. We are almost present in 60 plus countries. We have a huge knowledge base. We have expert teams globally, which are into automotive, packaging, medical, composites. We really leverage all these informations. We also did our own survey, and that's how we defined sustainability the way we do. And we try to bridge the gap. So that's one thing that has changed from a supply chain standpoint. Also, I think we are talking about biopolymers. We are also talking about India. India is making progress in biopolymers, but as Vishalji rightly said, not to that extent. People are investing into it, but again, you have banned single-use plastics way back. So why the time to bridge or build in capacities? So we also need to drive, we also need to educate. I think knowledge becomes very important. Knowledge sharing becomes very important because I see a lot of what we say principals of suppliers having a lot of knowledge base with their global expertise. But I think it's important to understand the customer's need as well. How we evaluate at IMCD is on a 2x2 matrix. So we see cost, we see the performance, and based on that, we are placing all the raw material solutions with us. So we are working globally almost with 64,000 products. And with that kind of knowledge base, I think we become very beautifully placed in this ecosystem where we can guide our principals, we can also guide our customers on what is the right solution, what is the right trend, how the economy is going forward, what is the right approach. Just to give you an example, we were talking about biopolymers, so there are solutions and sometimes cost becomes a big deterrent, but we worked with one of our principals, developed an additive where the thickness of the product was actually reduced by 1/3, which means you have basically reduced the cost almost by 70%. So that's the kind of solutions that a distributor or the supply chain needs to do rather than merely buying and selling. And that is what IMCD is doing here in India as well and as well as globally. So that is what we're trying to do.
Thank you, Nirjhar. One last point from Ashwinji, and then we close this session. This is about biopolymer and biocompostable. Strength-wise, how are they placed? And second, when do we see cost equal to what we can say other products which are available?
Yeah.
Over to you, sir.
I would just like to make one comment in addition to what Neeraj just mentioned, IMCD. I think it will be good to identify the value chains in various sectors, identify the various stakeholders, or call it part of the ecosystem, and all of them can work together. They will not be competitors, they will be helpers to each other. So we need to identify, for example, storage batteries, one example, automotive, another example, many examples are there. So identify the value chain and then find out your logical place and support both your supply side, demand side, and all that. So that's just one thought that I would like to share. You were asking about the biopolymers, degradability, etc. I would say the ideal definition of biopolymers is they have to be bio in the complete sense. They have to be bio-derived and they have to be biodegradable. Otherwise, many times you have bio-derived but not biodegradable, or biodegradable but not bio-derived. I think we need to complete that chain. And there are wonderful materials available. Some, like I gave the example, the old ones, which need to be seen again from a new light. And also, as I said, seaweed can be a wonderful material. And we have done some work on the bio-derived plastic from seaweed. You get one derivative which can be converted to bioplastic. A lot of work has been done around the world, including in India, and I think it needs to be given a push. And I think we can, because the polymers, as was rightly said, that we say that, okay, single-use plastics banned. But banning is easy for government. After that, you have to have a cost-effective substitute which will be able to do the job. I think policy is one thing, but we being able to deliver the result which is cost-effective, or even if it is not immediately cost-effective, you start at a higher level and then you can percolate down. So this is the way to do it.
Thank you, Ashwinji. Sir, your views.
Biopolymer and cost, if I say, biopolymer entered India maybe 5 years back in a true sense. I was a part of distribution of biopolymer before we went into functional polymers. Just to give you perspective, BBET was at $3, PLA was at $4. Typically in INR terminology, PBET was trading around 300 rupees and PLA was trading around 400 rupees. Today as we speak, PBET is available at 120 rupees. Very clear, near to polyethylene cost. Polyethylene is at 110 rupees and PBET is at same. So let's say you want to make a carry bag for a single-use plastic replacement. It is very much possible to make out of a biocompostable material because the basic resin cost has significantly gone down. So this is possible. What is not possible and what people are not looking at is that they are adulterating the biopolymer with a polyethylene. So you go in Ahmedabad, I'm a part of All India Plastics Compostable AICP, which is a compostable association. The biggest problem the manufacturers face today is, in spite of having certification by CIPET, the adulteration of bioplastics by a polyethylene guys. So they will mix a polyethylene with bioplastic. So when you go to government, they say bioplastic is not compostable, but actually it's the adulteration which is causing the issue. Second issue, PLA. Polylactic acid used to be at $4, India was a net importer. We have on last month, 27th, Balrampur Chini have launched 75,000 tons of capacity, up running by next year, expandable to 150,000 tons capacity. So India would have its own PLA by two big players, Praj and Balrampur. So India would come up into affordability. It's now us as a consumer. We as a consumer would have to be vigilant to go for not an easy solution, but we have to say, I want a sustainable bag. While we go to a Kirana store or a vendor or a mall, we should ask for a biopolymer as a single-use plastics. If we as a consumer start demanding that, the demand will go up, and hence with the demand, the industry will be able to feed it better. So biopolymer is absolutely possible as far as the single-use plastic is concerned. Let's come to what is called inner packaging of courier bags, carry bags, all that. It's already a commercial product. There is no problem with courier bag, carry bag. Even people like Amazon, they all are expecting. We are working with projects in straw industry. We are working with food packaging industry. So everywhere biopolymer is making its inroad. Coming back to what Sir just mentioned about industrial application, you can use a biopolymer, you can use a bio filler like a wood, cellulose, you can have anything which is bio-generated like a bagasse and make a composites and get into an industrial zone also. So these are solutions. You can use a chain extender, you can use a coupling agent similar to what you use in the industrial zone and still make a good biocompostable end-use industrial as well as packaging solution. But the consumer has to be really vigilant, the authority has to be really enforceable, and if we do combination of both, we demand a product which is bio as far as the recycle is concerned, then only we can talk about the true sense compostability or a biopolymer getting implemented. Thank you.
Thank you, sir. Vivek, if you can talk about the testing tools. 2-3 minutes.
So basically development and on composite side. So I'll specifically talk about composite in wind industry. That's the background I have and industry I'm representing. So as we are seeing that turbines are actually becoming bigger and bigger from earlier sub-megawatt to 15 megawatt offshore turbine, the manufacturing which is becoming more complex as well as the cycle time. how fast and how consistently they can produce these larger blades, which are now ranging in the range, as Mr. Neeraj said, that somewhere around 80 to 90 meters to going almost like 110 meters long and weighing more than 20 to 25 tons. So the problems which industries face actually is creating a demand for developing new materials. And what we see is particularly for wind turbine blades, 3 areas industry is working. One is developing more and more higher modulus products, which can reduce the requirement of reinforcement layer in the blade, which also helps in improving the process time of blades. Currently, for longer blades, it varies from somewhere around 3 to 4 days to almost like 10 days to produce a single blade. So that is the challenge which industry is facing. And second area where they are seeing is how they can improve or reduce the complexity around the difficult shape of the blades, where reinforcement layer is a challenge. And there they see a lot of defects coming and repair of blades is coming for manufacturing. So they are trying to do some automation in that, where the complex parts are taken out from the shop floor and they are making pre-shapes and pre-forms outside the shop floor and directly feeding into the blade mold. That also helps in improving the cycle time, reducing the defects, and they can produce parts more consistently. And third area I would see where the development is happening is, as even Yogendra said, that some pultrusion applications are coming, where they are finding that some of the blade areas where you need very consistent and strong reinforcement, how new materials can help, as well as new processes like pultrusion can help. So there we are seeing that new generation of high modulus glass like generation 2, generation 3, where you are making step increase in their modulus by 15 to 20%. Those are coming, as well as carbon is getting used more for pultrusion, where you are able to increase the consistency as well as alignment of the fiber to improve the stiffness of the blade. And these are the areas we are seeing the new materials developments are happening to improve the overall processability and consistency of the wind turbine blades. Yeah.
Thank you, sir. With this, we come to the end of this session. A big round of applause to all of them.